Good afternoon, everyone. My name is Don Parkinson, and I'm a Senior Engagement Specialist with Atkins Realis. Today, we are continuing our series of live stream and radio topics on the Northern Road Link project as it moves through the provincial environmental assessment and federal impact assessment processes. The topics we are covering parallel our project activities, so we hope these will help our viewers and listeners better understand the project and provide input along the way. The purpose of these discussions is to discuss various topics relevant to the NRL or Northern Road Link Environmental and Impact Assessment. And in today's live stream, we're going to discuss what would be involved in building the Northern Road Link, specifically focusing on building the road through the peatlands. And with me today is my special guest, Dan Kunzler. Dan's a professional engineer and partner with Dillon Consulting. Dan has significant experience designing and building roads in the boreal forest, and especially through the peatland or muskeg areas that characterize these landscapes. Welcome aboard, Dan. Good to see you again. And you and I have talked about this topic before, so I'll just hand it over to you, and then we'll probably ask you some questions at the end. But for those of you viewing, we do have a call-in number, so you can leave a question or a comment about the project or what Dan's talking about today, and we'll try to respond to you. So with that, I'll pass it over to you, Dan.
Thanks a lot, Don, and appreciate that introduction, and hello, everyone. Today we'll just be discussing, as Don alluded to, a lot of the elements regarding the construction, maintenance, operations of the Northern Road Link, and how it kind of traverses the design process and into the construction, including camps, fens, and quarry sites, etc. With that, maybe we'll get the slide deck presentation going, and we'll go from there. So what will the road look like? So pictured there is an image, pretty much the same line of latitude, just a little bit west in Manitoba. And this is the all-season road to Bloodvein and Barons River First Nations. Again, very much similar terrain. Here we're in a forested portion. But the Northern Road Link will be around 160 kilometers in length. We now have a bit of a preferred alternative. And so it's a defined corridor and alignment, and two-lane gravel road. And when we say two-lane gravel road, it will be a very wide road, 12 meters in length, or width, I should say, and posted at a speed of around 80 kilometers an hour. So it's designed for 100 kilometers an hour, but it'll be posted for around 80 kilometers an hour. Next slide, please. So again, where are we? We are the blue corridor that you see there is the Northern Road Link, wedged between the Webequie Supply Road that you may be aware of, the yellow one to the north, and the Martin Falls Community Access Road to the south. And so the focus today is on the blue section there. And of course, we have the preferred alternative that we'll have a slide that speaks to that later on in the presentation. But why this matters, because it's more or less looking at the single functional corridor where benefits flow both ways. The resources out, but critical supplies, healthcare access, social and economic sovereignty in. Next slide, please. So we'll just go through some road construction 101 basics here on the next slide that goes through the steps and processes of construction. So of course, before any of that occurs, that blue box you see there, the pre-construction activities, the file's been open now for many years where we're garnering and gaining value component study information, sensitive site identification, traditional knowledge, a lot of community and stakeholder meetings, and listening to understand, to pivot, to adjust as necessary, and a plethora of environmental studies as well. So as we go through, we clear the right-of-way, and the next picture there, you see the aggregate production in quarries. There's millions of tons of aggregate that have to get processed, and then the grading and graveling begins, the shaping of the road, drainage components, culverts, equalization culverts. And what we mean by that is, we'll come to this later in the presentation, but we really want to not disturb the groundwater regime and maintain that hydraulic conductivity with where the road is going. Larger watercourse crossings, of course, require bridges. So there you see sheep pile cofferdam. And so bridge construction and installation. Then once we're finished with areas, we want to revegetate and provide erosion control measures. In this case, we do a lot of science looking at propagating the seeds and what's in nature now to make sure it's remains the same and we're not introducing new species to the area. And to that end, the next box, hopefully, won't be too relevant, because on the east side, for example, because we did that, we're actually not having to mow. The road's been open 9 years now, and there hasn't been any mowing necessary. It's back to what it was naturally in terms of the low vegetation in the forest. If you do happen to have issues later on, there's concerns with washout repairs, drainage preservation, and I guess, of course, in the wintertime, snow plowing. And again, in this area, we indicate here sanding, spreading ice, and dust control. But in this case, gravel roads primarily, we use ice blades on the graders in the wintertime and refrain from a lot of sanding and no salt in those areas. So that's high level, the road construction 101. We'll move to the next slide. So building in the north presents challenges and considerations, of course. The natural habitats. We want to, again, as I mentioned in the last slide, leave no footprint, basically. We want to return the area to what it was before we came to do the construction of the linear road. You want to make sure you have experienced contractors, workers, and businesses. It takes a lot to logistically organize this operation, and then also to be able to address the construction operations in a remote nature and in the Canadian Shield and swamps and fens that we have. And of course, safety considerations, of course, with remote locations as well. In this day and age, communication and to that end is a lot more easier with the technology that's out there now. But you never want to underestimate that and have plans for flooding, wildfires, nuances that we're experiencing even these days with projects on the go in remote areas. Next slide. So we'll spend a little bit of time on engineering and construction challenges. What you see on the left side there is a cross section that shows, the road. Those dashed lines you see are different layers of aggregate, if you will, and coarse material on the bottom. And as you proceed up, you have finer material until your surfaced traffic gravel gradation of a smaller stone. So on the right side, you see three pictures there. One is the clearing and grubbing operation and what's left there. And you can tell that this is, again, a picture of similar latitude to that project I alluded to in Manitoba. Lots of water, fen boggy terrain, peatland, and we basically just take it down to ground level. We don't excavate beyond. I'll get into that a little bit later. And we introduce woven geotextiles, geogrids, to bridge that interface of the natural ground and the rock that we put down. The next slide shows swamp mats on the, Tony, if you can go back. The next image, I should say, shows the swamp mats. And that allows us to, without, I alluded to reducing our footprint. And we can get equipment, trucks, and other equipment up and down this area to bridge the construction zones. And so those are swamp mats that are then picked up and repurposed and reutilized again on other projects. And the bottom picture there you see is what we call muck. It's the drilled and blasted quarried stone, if you will. It's not processed. This is just right out of a grid pattern that was drilled and blasted. And the dozer, the way it pushes that material, it naturally allows the coarse material to fall and the fines to migrate to the top. And looking at that left diagram there, the cross section, that's that bottom layer that you see there underneath that first dashed line. And you'll see a berm there as well. And rationale there is, again, just to account for settlement. We know that this is going to settle 30-40% the thickness of the peat layer. And so that just provides us that cushion of the footprint that we need for maintaining the road cross section that we're after. The other thing that does, and I have slides later on that show it, but you can see it here now. So that area is being constructed. What you see there will actually consolidate and sink, and that porous stone allows for the hydraulic conductivity to continue. All right, next slide, please. So overcoming challenges, so innovative construction techniques. So we've had to learn a few lessons through different approaches, and we'll get into that in this topic here. So mobilizing of bridges during winter and summer months. Again, up here, you want to approach your bridges with a nuance where it's the sites are similar. The girders are steel girders in all likelihood, and consideration of highly variable bedrock. Again, we want to build out of the bedrock that's not moisture susceptible or materials. And then efficient communication during unforeseen circumstances. So coming back to that whole communication nuance and making sure that there's a means to be able to communicate with either stakeholders as well, but in terms of notifications of work, but also for those unforeseen circumstances with contractors and design team that they can collaborate together. So construction camps. So the Northern Road Link will have numerous construction camps operating during the construction phase. These will come in different configurations, roughly 50 to up to 200 person camps, depending on the nature of the surrounding construction. They typically consist of dorms, kitchens, of course, rec rooms, water tanks, parking, equipment yards, generators, propane, and again, our next slide will show a few things here. So in the right, you see a little bubble there showing the map of the road. The maroon figures you see there are potential quarry sites. Then, of course, their waterway. And we strategically locate these camps so that they're close to multiple operations. That way, we're not building so many of these construction camps. And the picture you see here is an average 100-person camp. The bottom bigger rectangle is a larger dorm where the contractors' staff quarters were. The right side shows two separate sort of squares. One of those is more the kitchen rec area. Another is the design CACI, the engineers' quarters for living. The top left shows two longer rectangles. One of those is the site office for the engineers and the other site office for the contractors. And then you have boneyard to the north of that, boneyard being where the equipment is stored. So that's sort of the layout. And you'll see here when we pivot to the next slide, how we decommission. And we pull out the access road that goes into the construction camps. We provide that drainage where you see the ditch and the all-season road there, the darker area, and make sure that traffic is no longer permitted to go in and out. And then, it could be reforested as well, depending on the nature of the ground surface. That black area you see on the right side is the quarry site where previously I would have been drilled, blasted, and mined for the aggregate needed to build the road. Next slide, please. So construction and operating and maintenance of the road, how do we maintain it? So on the left side of the column there, you see the highway component, and on the right side, you'll see the maintenance and activities. So the highway surface shoulders, there'll be grading and blading of the road, grade repairs and dust treatment. The dust treatment, we're moving away from calcium chlorides, magnesium chlorides, and going to more environmentally friendly products that aren't as harmful on the environment, but rather actually made of natural ingredients. Drainage, of course, cleaning, inspecting, culvert repairs, replacements as necessary. An approach we take with these types of roads is, even though it may warrant a smaller diameter culvert, we don't put in anything less than a 900 millimeter culvert, just for efficiency, for even beaver maintenance and so forth, just from plugging up, for steaming, less steaming issues as well. It doesn't freeze up as frequently. The next highway component is the bridges. So again, these are going to be inspected. Their service design life is anywhere from 75 to 100 years. But they do require routine maintenance and repairs as necessary. The roadside. So when we talk the roadside, it's when we're off the road, the ditches, the right of way, the area up to the standing timbers that weren't cut down. So again, there's brush, debris, litter removal. Here, again, I mentioned earlier that we hope to not have mowing issues. We want to propagate and put back into the ground what was there by Mother Nature originally. Winter time, we of course have snow plowing operations. Traffic services, we look at the signs, maintenance, traffic counting as necessary, and service functions. So here we have highway patrols, equipment servicing and repair, material crushing and stockpiling. And what that alludes to is on a road like this, often what's done is on say a 3-year cycle, they'll do crushing of aggregates and build stockpiles. And on an annual basis, you'll pull from those stockpiles and be treating the road with that material and essentially adding to the road top of material. What's not mentioned here is we will probably have roadside turnout rest areas, if you will, throughout the length of the whole road network. That's to account for both maintenance vehicles, rest areas, and just an area for folks to turn around, be it in a maintenance vehicle or public at large. So now pivoting and focusing a little bit more on building roads in the peatlands that I touched on earlier. The next slide, please. What we're looking at on the right is very indicative of the terrain that we'll have in certain areas. And the peat has different layers. I won't get into the science of all of that, but that water table that you see fluctuates, of course, in different fens, bogs, and swamps. And as our goal with this, again, is like I mentioned earlier, to maintain that hydraulic conductivity, the water flow through the embankment. And what we did on that east side road to Barons River and to Bloodvein was we did a few approaches. We initially chased the peat, thinking that we're going to get down to better ground, whether it's clay, till, and put our roadbed right on that. Well, that introduced water management headaches for the contractor and us. It affected some of that groundwater movement. And what we learned is it's better to, quote, raft over top of that terrain of the peat fens and bogs, and to use that geotextile, geogrid material, put down that coarse stone, let it settle, and by installing piezometers, water measurement devices and instruments on the outside of the road at the prairie where it meets the natural vegetation, both pre-construction and during construction and post-construction, taking readings has been a positive result, I should say, in that the water quality and quantity remains the same on both sides of the road. There's often concern that with a road grade coming through, may be plugging and affecting that flow of water. And by introducing this construction approach, and again, I mentioned that the 30-40% consolidation of the peat, even though that's occurring, that coarse stone allows that water flow through. So that's what we're up against, and what a solution that's worked for us. So just wanted to show that slide here again that we had from earlier, and basically I just spoke to all this in terms of maintaining that hydraulic conductivity. Revert back to the next slide. So that lesson learned was an important lesson. Chasing shallow peat often introduces those water management challenges, and the floating is often a superior approach. And we're trying to source those local materials to minimize our hull factors as well. So as we select these routes and alignments, We do so in conversation with stakeholders and information gained from the science teams. And we are always looking for, okay, where are the quarry sites, potential quarry sites that we could tap into for getting that coarse material through those fen bog areas. Once we're on decent terrain like eskers or till areas, we know that we can make use of even closer materials that are till in nature, sandy in nature. We don't need to chase the bedrock for those sites as much. Next slide, please. So again, that's an aerial image showing the route to Barons River. You can see that you're coming out of a fen bog area and back into tree area, and that'll be the nature of our terrain as well. We're in and out of those types of areas. The piezometers, again, very much confirm that the road maintain that hydraulic conductivity, and we're trying to limit that environmental footprint disturbance altogether. Next slide. So quarry sites, again, is where we're looking to get the bedrock that's needed to build through those areas. We won't have limestone in this area. It'll be granite in nature, and the hardness of that granite may change here and there, but we, on the science side, take readings to account for those changes. Next slide. So what do we need again for materials? So we have that road base, which is the coarse material, the road base, the gravel on the top layers, the foundation of that subgrade that you see in the picture there of the coarse stone. And we need, of course, the culverts. Those are corrugated steel culvert typically. Depending on the natural pH of the water in the areas, to prevent them from turning orange. You may have seen that in your travels. We want to gather what the natural pH of the water is, how acidic it is. And there's options in terms of galvanized culverts, aluminized culverts, or poly-coated culverts as well. And then, of course, the maintenance, the annual graveling. I mentioned that earlier, how we'll crush every 3 years. And then pull from that material on an annual basis to gravel the road. Next slide. So now moving into the crossings and the structures. So on our northern road link, we have 14 bridges. 7 of those are clear span, 7 of those are multi-span. By that we mean that there's going to be piers on those 7 sites. And then there's numerous culverts that I spoke to that are a combination of closed and or open bottom. Here, this picture shows the bottom one with the white truck is the permanent bridge. The one on the top of the page that kind of looks like a truss almost. It's called like a modular bridge. Could be Acro, a Bailey, and Algonquin type of bridge products that are out there. Those are more temporary. They go up quick. You can span almost 100 meters, 300 feet plus or minus with those, and they provide heavy load that you can carry heavy loads across them, and they might actually be a means to getting the Northern Road Link constructed quicker while the permanent structures are being built parallel. As you're building those permanent bridges, often contractors need working bridge platforms, and these are some different pictures that you see. The left one, you see the barge just on the bottom, with the permanent bridge being constructed with the crane on it, and the round piping that you see is the pier construction being constructed there in the middle. The other ones are, again, other potential working bridge platform options as well. Next slide. So here's a picture of one of the bridges on the East Side Road up to Bloodvein Barons River. And so this is a multi-span bridge with 2 piers that you see there. And again, those steel girders are common to what we'd be using for an approach on the Northern Road Link as well, where you can truck those up. They're not precast, pre-stressed concrete channel girders. They're robust in terms of shipping, and then you see the abutments on both sides as well. You can see on the left side how the abutment is pushed back and basically making use of all the natural keeping as much natural as we can. Same thing on the right, just tighter in terms of the structural requirements. Next slide, please. So the watercourse crossings, there's numerous. The Attawapiskat River will be a picture on the next slide showing that WC32. And just like you saw in that previous image, this next image of Attawapiskat River will be a multi-span bridge, very much like that. If we go to the next slide. So that's the picture of the Attawapiskat crossing looking east. And again, quite long in length and very similar in terms of approach that would be taken with the picture you saw earlier. If we do go back one slide, I just forgot to mention the alignment that you see there on the right, the corridor there. So the gray that you see is the area, the other alternatives that were being considered for crossing the Attawapiskat. So the colored ones that you see in those nodes is the preferred corridor. All right, next slide, please. So engineering work done to date. What you see here, just before we go to the next slide, is stripping of a rock cut. So we'll take off the overburden, and you see the cap there, the red cap, set up the grid pattern accordingly. So contractors will set up a tight grid and for a finer blast, and a larger spacing grid for a more coarser blast. The deeper you go with your drilling and blasting, the more control you have over limiting the oversize you have. So next slide. So we've looked at, of course, the route alternative assessments. We've compiled conceptual draft plan profiles at a high level. Structural watercourse crossings as well, looked at those. Evaluation and recommendation of alternative routes. Of course, we're coming at it from a technical lens, construction costs, schedule, all those factors. But again, listening to the input of stakeholders, the team, the science teams to initially come up with the routing. That's what that next bullet there speaks to in terms of the feedback from Aboriginal treaty rights and interests and Indigenous knowledge and the science teams. So we're looking at adjustments in the coming months to finalizing those alignments and tightening up our high-level costing and scheduling. You see there on the left a triple barrel, large barrel site for a crossing here. All right. Oh, Don, I think you're muted.
Oh, I should be. Am I back now? Perfect. Okay, good. Thanks, Dan. Great presentation. Really interesting. One question for you that I've heard on, on other projects, they do preloading or surcharging of the road. Why? What do they do that for? And would they be doing that? Would that be done on this project?
Great question. So yes, actually, it will be done on this project as well. We did it on that East Side Road project that I alluded to as an example, primarily at the bridge approaches to the bridge sites. We'll have oftentimes. I mean, it'd be great if it was bedrock at each one, but we don't have that utopia. So we have the swamps, fens leading up to that in places. And we'll do drilling, blasting, load, haul, place that muck, that large stone, and let that consolidate for sure a year, if not 2 years, before we come to site to do other work. In the areas of the general road, we work year round with these sites, of course. So in the wintertime, it'll look a little ridiculous because we're building the road so high. But again, come spring, it will settle. So we see the immediate consolidation in the summer months quite quickly, and but in the winter months, we account for the fact that it's going to settle come that following spring, summer, and we overbuild on purpose.
Oh, that's really interesting. Yeah, that's good. Tony, did you have any questions for Dan?
I do not at the moment.
Okay, well, with that, Dan, I really appreciate.
Just give me one chance.
Sorry, Tony.
I'm going to check the call-in studio log and see if anyone connected.
No, that's really interesting. So the work can be year-round then, can it, Dan?
Yes, that's the beauty of the working with the bedrock and the quarry sites. It's not moisture susceptible, frost susceptible. It can be used and built with in rain days, in winter months, summer months. So that's the one blessing of this construction approach.
Yeah, no, that's great.
Dan, did you find that there was any dual uses for communities for some of these sites afterwards? Because I know, the laydown areas, they're already kind of cleared and constructed, and they have buildings. Did you see that use case in Manitoba?
A little bit when those laydown areas were in closer proximity, they could become repurposed for cultural campsites too, for example, where it could be utilized for other intents, or again like a future maintenance stockpile site is what we try to use them for as well, so that they're not just left unattended. Where we can, we repurpose them for different needs.
Oh, well, that's interesting.
Mm-hmm.
Well, thank you, Dan. And with that wraps up today's discussion. We hope it was helpful and encourage you to join us again soon. Don't forget to keep in touch with our project team members via the contact information available on our website, northernroadlink.ca. Miigwech, and make sure to look out for our project updates on social media and our website.